Hi. So good afternoon again, class. Today I am discussing the syllabus with you. And so welcome you all to the summer 2 class of BIO211, which is Biotechnology and Society. This is an asynchronous class. And in the asynchronous class, I believe you know by now that there is no specific timing that we have to meet. And in that light, I will be posting all the recordings for each and every chapters on the Blackboard. But there will be a specific office hours. There will be a specific office hour every day, Monday to Thursday, between 1 and 2:30 p.m. So I will be teaching during that time. And anybody who wants to come and have questions or listen to my teaching, then you're most welcome. So my name is Shiraz Mujtaba. I am in Department of Biology at Medgar Evers College, and I am associate professor. My basic qualification is PhD, and my PhD is in the area of molecular biology and of HIV. I did my PhD long back, almost 20 years back. And after finishing my PhD, I came to Mount Sinai to do my postdoc, and I continued to work on HIV, and then I started working on cancers. Specifically P53 gene, and then I started my academic career. So I have given my office address on the top part of the syllabus, but we are online virtual since last 1 year or more than 1 year now. So so I'm going to the second page. Now, before I go to the second page, I just want to quickly define what is biotechnology. So biotechnology is formed by two words, bio and plus technology. Right? So now bio means life, right? And technology. So I'm sure I don't need to go into deep, but we all know that all across the world we just had a COVID pandemic, and within no time there were struggles, there were challenges in the beginning, but sooner the diagnostic tests were available, and these were let's say RT-PCR, and then we have the vaccines. So all these are possible. So this is a direct correlation between health or life and the merging of technology. Now, when this merge happened, then if this leads to commercialization, right? Such that there is a company or corporate, and that makes profit, and not only profit, but let's say it gives jobs, and it creates it helps economy. Then we have a perfect example of how technology affects society. So biotechnology deals with to develop a commercial product in the framework of biological concept. So what is a biological concept is that this is, we were having COVID-19, and we know that this is virus and this is an RNA virus, okay? And then this is an RNA virus, and it can cause many illness, but primarily lung sickness. So we all know this, that these are the problem with COVID-19, and we have to treat it. So now this is an infectious disease. So what comes to mind is a vaccine, and first to detect that. And I remember I myself was infected with COVID-19, so it took a long time to get the results. Almost 2 weeks. Now it is, I think they gave it same day, most likely, or in one day. So how did it pace up? It paced up because of the technology. So technology is combined with health to deal with challenges or to improve the health. For example, like vitamins or newer medicines. So all these that impact human health and diseases, when they come under a commercial framework that would benefit a society, it becomes biotechnology. Okay, so this is the significance of this course, that we learn not about the biology, but also regarding the biological concept and how these concepts can be developed into an idea, and this idea can be commercialized to help the society. Okay, so let's look at the course overview. That biotechnology and society is a course designed to introduce students to the field of biotechnology and to the application and the impact of modern biotechnology on society. So the history of biotechnology, right? So whenever we are at a stage in this century, in this period of time, where all the information is available on cell phone, and you can essentially Google as long as possible to what was done 1,000 years back, what was the history of Egyptian pyramids, or more ancient discoveries. It's all available on let's say Google platform or even on Facebook. So this information era, we are in an era of information building, and so this course is important that we built upon basic concept, and these basic concept can be connected to the need of today's society, today's, it could be locally, it could be globally, right? So that's the significance of this course. Now, this course or every course, it has a guideline. Every course has an objective, right? So what is the objective of this course, right? So the objective of this course is that is listed here. So now, what is the significance of this course? So this is, so a course is typically a business plan. Business plan that is offered by, let's say I am delivering at the end, but this course has been developed by the department, a faculty that has been approved by college. So it is very important that this course, whatever is committed in this course, should be delivered to the students. So so the course objective or student learning outcomes is very important. So number one, the student learning outcome is discuss the definition of biotechnology, the history, the fundamentals of modern biotechnology. So just now, very briefly, I defined biotechnology. History, biotechnology, you can go as early as possible, when human civilization. So humans in the very beginning, we used to travel from one place to other place in terms of food, shelter, security. Then at a certain time, the civilization or humans, we planned to settle down. Why did we settle down? Because we wanted uh, to be accessible to water all the time. We wanted to develop, some kind of livelihood. So one of the earliest profession that human beings had was agriculture, food, right? So if you live near water, so you will see that most of the ancient civilization, they settle near, closer to water to help themselves. And then when they stick towards water, then they had take care of their food, and they came in close contact with soil. Now, on soil is a ground to grow food, but in the soil, surprisingly, there are not many bugs that can infect human beings, right? So the human being had a necessity to pet like horses or cattle or dogs. Now, when humans they came close contact with these animals, animals could have a disease and that could be passed on to humans. So human beings came across with epidemic, pandemic like plague that was passed on by mice, or anthrax that were passed on by cattle. So, so the history of human diseases and goes very, very long. And then, many times as a part of a community, as a part of a household, they started fermenting rice products. So fermentation is also part of biotechnology. Now, these fundamental concepts, if you take it and come to now, it is same thing. We are facing pandemic, and every time it's a new pandemic that has a devastating effect on humans. And we go back to we go back and see how, how we dealt with plague, how we dealt with the Spanish flu, or how we dealt with polio. So, but we are in an era which is high wire era. We are connected so much, the information. Every day, I think in the noon time, you get an update from New York's Department of Health. How many people got infected? How many people are positive? How many people passed away because of COVID-19, which was not available then. But challenges are same, but we are riding the crest of technology, and that's to help humans and on ourselves. So that's, I again went through different definition of biotechnology, and I'll keep coming to this this concept of biotechnology. Demonstrate the knowledge of basic biology. So as I mentioned to you, basic fundamentals are those ingredients in which you build buildings. These are building blocks. Basic information, for example, English alphabet from A to Z, or numericals from 1 to 100. If we don't know those basics, how can we write a word? How can we write a sentence, right? So this basic information of biology is very important, right? Discuss and identify. Number 3, identify the basic principles and common terms of techniques of recombinant DNA technology. So after we have discussed the basic concept of DNA, protein, and everything, then we go into the applied aspect, recombinant DNA technology. So what we have vaccines here is some of the modification, alteration, modernization of recombinant DNA technology. So we can't build recombinant DNA technology without knowing the basics of DNA. And bacteria, on one hand, they are our enemy. They can cause many kinds of diseases, but on the other hand, scientists use bacteria as a factory to make various recombinant products, right? So let's go to number 4. How does this modern biotechnology helps our agriculture? So GMOs, right? Genetically modified plants. This is a product of biotechnology. There are controversies which should be, there should be debate about how safe they are. But at the same time, the promises that genetically modified organism or plant make is a lot to reduce the price, to make things available around the clock, make it available globally, right? Make it disease-free, make it more healthier. So that is the direction where the modern biotechnology is going. The same thing about the medicine. So you can say millions of population across the world got vaccinated, right? And yes, there is debate for and against vaccine. I'm not going there. Cancers, cancers are very, very difficult disease. So the new medicines, new drug targets are being developed. So, this course should form an opinion. What are the positive or what are the negative impacts of technology on society? And one should debate. Debate doesn't mean argument, but you can debate to ourselves. I'm sure everybody is thinking, we are using cell phone, but we know that it is not absolutely safe or healthy. And should it be used in a certain way or for a certain time, or it should be unlimited? These days, everyone in pandemic, we went fixated on all these electronic gadgets, and all this technology also impacts us mentally, so, and diseases also impact. For example, lockdown, it affects us psychologically. We haven't seen our friends, our colleagues, we haven't traveled, to meet our relatives and people who fell sick, who were passed away. So we went through a different kind of a trauma that affects health. Now, there are many apps came into this to keep track of, what is that called as contact tracing. So, to make us ahead of time to predict pandemic. So, so technology has given us a lot in this past 1 year. But at the same time, it has affected us positively as well as affected us, negatively. For example, Zoom syndrome, all the time sitting on Zoom, attending conferences, we are sitting, we are listening, but it's very, very tiring, So, and yet, despite so there are many, many things, there are many layers to what I'm talking about. But with the help of technology, we can understand some of those tough questions, right? And this will help us to design our future, future goals. Then, so thinking, learning, and deciding, decision, critical thinking. What are the future challenges, right? Will there be a new pandemic in next 10 years, next 20 years, next 50 years? So this year, last year we had COVID. Before that, it was Zika virus. Before that, it was Ebola, and sometime various kinds of dengue virus in all across the globe, HIV. So you can see, no matter how technology is robust and doing good job, but there are future challenges, and so these are the student learning objectives. So briefly, if I have to define what is the student learning objectives or outcomes, is that in this class, through this syllabus, through me, as a messenger of the syllabus, you will be learning basic knowledge of biology and how this basic knowledge can be translated into products. How can those be an idea? And in future, you can have an idea and you can develop it and you can take benefit. So right, the basic message is that you strengthen your fundamental, get your own ideas, try to protect those ideas through patenting and regulation, which is point number 6, and you're ready for future time, right? So that you get the fruits of your hard work or your ideas. So these were the student learning objectives. So the textbook, I will just show you the textbook. The picture of the textbook, it is available on Amazon, and this is I'm trying to go to the Amazon page, and I'll show you in a brief moment. Biotech Demystified is the name of the So let me share the book. So this is the book that I'm showing you here. I hope everybody is seeing. This is the book. This is available on Amazon, and it can be delivered, I believe, overnight. It used to be, but I don't know in today's climate. And you know, this is paperback on Kindle, various, various way you can access this book. So that was the information on book. Going back to the syllabus. During the course, I will cover some of these articles. So there are 56 articles that are listed, and at a right point, I will integrate these articles into the syllabus, into my teaching, and would go over it. I also might put these articles on the discussion board, and then I will like to know your comments and your understanding. This is the grading policy here. Assignments become very important, and especially in summer or winter, because it's very short and every day will be covering a chapter, and then every day there will be assignment. And assignment, I will go to the, you can submit on the Blackboard. I will show you how to do that. And then we'll have discussion board, that is 10%. So discussion board is one of the very important things, because that's the way I can learn that how much you're participating in the class. So there will be small questions, general questions, and I would like to answer. So homework or assignments that will be due every week, because every day, sorry, because of the nature of this semester, summer 2. Then there will be quizzes. Now again, I have written here bi-weekly and weekly. It could be alternate days or after 2 days, because again, this is a summer semester. Things are going to go by very quickly. Then midterm, at certain point when we cover 50%, 50% of the syllabus, we'll have a midterm. Most of the questions will be multiple choice questions, and so we'll have quiz number 1, let's say chapter 1 or chapter 2 together, then quiz number 3. So midterm and the final exam, it will be cumulative, meaning that whatever number of chapters, topics we have covered until that point, we will have the exam on that. An exam will be multiple choice questions, right? And then we have a term paper. The term paper is due on the day of final exam. So let's say the semester ends, let's say, just for sake of example, on 20th August. Then on 20th August, this term paper will be due. So tomorrow or day after, I'll be uploading the term paper and all the guidelines for the term paper. Final exam will again be multiple choice question, 25%. It will be on the last day of the semester. And this is the typical, grading scale that is all across CUNY. So you can see on the syllabus. So you can see that assignments are very important, 20%. Of course, exams are important, but I advise you not to leave any discussion board. Small things counts, towards your grades. So don't think that 10% is less or 20% is more. Sometimes, I've seen, based on my experience, that everything. I believe you're doing taking summer course, or this is so you want to do good for yourself. So make sure that you attempt everything that is laid on the. And overall, this is a very simple course. It's not at all challenging, and it's the feedback I have from students is that this is a very easy course. But yes, you have to be on top of it, because even easy things, if it keeps accumulating and you're not addressing the expectation, then it can become harder in the end. So this is again, before I go into the syllabus specific of teaching content, this is asynchronous system. I have given the time from 1 p.m. to 2:30 p.m. in which I'll be teaching, and I could be recording. I have already recorded these lectures. I have edited those lectures and they are ready, but I still want to come to the office hours and go through the chapter quickly, so that if anybody has questions, then I can answer it. So what is in the summer? And so this is I have posted or uploaded a semester syllabus from the semester system, but what is written here as week 1 and 2, we are going by day 1 and 2. So in day 1, I'm going to review the syllabus. I am going to tell you what is biotechnology, which I have already told, and historical development of an old science and powerful new technologies that I briefly mentioned to you, and I'm going to keep mentioning it. Biotechnology, multidisciplinary science, career prospects in biotechnology, so and so forth. So that's day 1 and day 2. Now I want to focus here regarding macromolecules of life, right? So what are the macromolecules of life? The macromolecules of life are those molecules that support life. And why they are called macromolecules? Because they are very, very big size, right? So for example, what I would suggest here is, for macromolecule is number 1, proteins. Second, carbohydrate. Lipids. Fourth, nucleic acid. Now, I'm not going to go into the detail. I'll go into the detail tomorrow. But these are the 4 blocks of molecules which form which are building blocks for our cell, right? And an organism could be single cell or multiple cells. Protein has very important role in providing infrastructure. Carbohydrate provides energy. Lipids provide another form of energy that we'll talk later. Nucleic acid, it is the genetic material, DNA and protein, right? So we will go into the details. These are also called as biomolecules. Now, one thing very interesting I will tell you from today's diet point of view. So carbohydrate essentially is sugar, right? And lipids, so this is very interesting. I'm not a physician, I'm not a dietitian, I'm not a nutritionist. But what I'm reading these days, that carbohydrate is now being thought as a problematic diet, because carbohydrate increases the sugar content in the body, and the sugar content in the body can lead to diabetes or obesity or various kind of metabolic disorders. Lipids, on the other hand, fat are now, which was avoided. People used to avoid fats in the beginning, that, they used to draw direct correlation that, okay, fat in the diet could lead to deposition of fat in our blood vessels, and that could give rise to heart attack. It is possible. But now, it is now thought that lipids, if our body runs on lipids, then we generate more energy, and there is less problem. So this kind of change in biochemistry is being researched now in terms of metabolism, because remember, we have switched our eating style from homemade food, organic food, to genetically modified plant, which could be absolutely be healthy, but we have gone to frozen food, fast food, high calorie diet, all those drinks. So where do we get the knowledge from? We get the knowledge from these fundamental molecules or macromolecules. So this we'll talk tomorrow, but I'm again trying to reinforce the intention of this course is to learn about fundamentals of biology and to develop, a product that could help. For example, protein drinks are very popular now because protein drinks directly, protein would directly affect muscles and cells. And then coming to nucleic acid, we talked about recombinant DNA technology. The COVID vaccines that we are getting it's very interesting, new concept, new approach that an RNA or mRNA has been developed into a vaccine, right? So we'll talk about these molecules tomorrow, but that is the message that is there in every chapter, that we know the basic concept, the fundamental concepts, and then we built our idea. Then go into the introduction of living things, prokaryotes versus prokaryotes are bacteria, eukaryotes are like human cells. The bacteria are very important for supporting recombinant DNA technology that we'll study. Cellular communication, how does cell communicate to each other? Let's say this is week 3, so maybe if today is Monday, we could cover this week 3 on today's Monday, Tuesday, Wednesday, or Thursday. We could talk about this cells and how do these cells talk, what are they made up of, what is cell membrane, so on and so forth. Then the essence of every cell is to divide, right? Especially the single cell bacteria. Bacteria can fill the whole environment provided we give them the nutrition. Human cells or eukaryotic cells will see the difference, what is the difference between prokaryotes and eukaryotes, but the basic quality of life is to divide, grow, and develop. But it depends upon something is unicellular or multicellular. So cell cycle, mitosis, and meiosis, we are going to talk about in 3 to 4 days. Then, so look at this, the nature of the course. First, we talk about the history, we talk about the definition of biotechnology. Then we talk about cells, how cells look, what is the difference. Then we go into cell division. After covering cell division, then we go into the DNA structure and function, which is the DNA blueprint. How does DNA replicate? How does a dividing cells get the daughter DNA? How does DNA gets mutated? All this information. So, and then we talk about inheritance. Now, these looks a very intense biological topic, but in this course, in this syllabus, it is very simplified, such that everybody can understand and can get some information from it and can think about making careers. Then we talk about inheritance, how human diseases are passed on from one generation to the next generation. But we are not going into those complex diseases or complex human diseases. We talk about fundamentals. How did Mendel did his work, so on and so forth. Molecular cloning techniques, again, coming back to recombinant DNA technology, so on and so forth. From where this word recombinant came, how the DNAs are cut and joined by the bacteria and so on and so forth, cloning vectors and all those things. Then we talk about protein biotechnology, and protein biotechnology is proteins are the backbone of vaccines and various other things. And proteins, for example, let me take an example of protein biotechnology. So we have in our body, we have in our body red blood cells. Within this red blood cells are special proteins which are called as hemoglobin. Right? The function of hemoglobin is to carry oxygen from lungs to every cells of the body, and then take carbon dioxide from every cells to the lungs and release the carbon dioxide. So this goes on. But in certain unfortunate cases, the DNA for hemoglobin is mutated. So these individuals, they have sickle cell anemia or hemophilia. So they have to go through all the time transfusion, and transfusion is very, difficult. So we learned about how protein is important in this chapter of protein biotechnology. Right? So I'll just take a break here and try to take your questions. I'm not seeing any question in the chat area, but you could unmute yourself one by one, or if I see hands raised, then I can you could unmute and ask me questions. And this is being recorded so that other students can be informed about this information.
Hi, Professor. How are you?
I'm good.
Good.
How are you?
Good, thank God. I was just wondering about the discussion boards. How often will you be doing them?
Most likely every alternate days or 2 days. Every alternate day.
Okay, I was also wondering about the reading material. How are we supposed to access that ourselves? Are you going to be sharing some of it with us? And like, if we have to get it ourselves, where should we go to get that?
Good question. So I will post every day a learning activity, right? So learning activity tomorrow is 20th July, right? Tuesday. There will be chapter number 1 on biomolecules. I'll put the slides. I will upload the slides. I'll upload my recording. I'll upload the assignment. I'll upload the place to submit the assignment. So every day there will be specific learning activities, which will be composed of slides, my lecture, and recorded lecture, assignments, and a discussion board.
Okay, thank you. And I was also wondering if you have dates for like the midterm and the final yet?
No, as we progress. So let's say I will take midterm after I finish the inheritance, the Mendel part. So around that, when I finish, so that's the first 4 chapters of this course is a bigger chapter than the rest of the chapters. So once I finish those are fundamentals like biomolecules, how DNA replicates, what are cells, prokaryotes and eukaryotes, and cell cycle and all those things.
Okay, thank you.
Yeah. Any other questions? Okay, if there are no questions, then I will go back to the syllabus. So we spoke about protein biotechnology, and then we talk about, so as I mentioned to you, the first 4 to 5 chapters are bigger chapters, and we'll have midterm around after I finish the pattern of inheritance, something this chapter or recombinant DNA technology, somewhere along this line. What is listed here as week 6, or it could be 2nd to 3rd week, we could have a midterm. But before that, we'll have several quizzes. Then we talk about the role of biotechnology in agriculture and animal biotechnology. Now, week 10th is biotechnology and environment. The environment has come into greater attention in many ways, and one of the challenging part of the environment is the disposal of waste material. And for example, plastic, plastic is not degraded easily. The use of various kinds of herbicides in fertilizer and so on and so forth. And then biosensors, how do we detect pollutant, right? Because the forest is being reduced thin and thin, and the human population is increasing. It was perhaps bound to happen. So less forest, less greenery, more human population, more demand for food, so more waste. So how do we handle the waste, right? So then aquaculture biotechnology, it directly deals with fishes and seafood, because these are the bigger commercial products. Every restaurant, from right all across the world, they use fish as a staple diet, which is rich in protein, rich in unsaturated fats, and so on and so forth. Then we talk about stem cell biotechnology. This is a emerging field. So we know about stem cell biotechnology or stem cell technology, but now it is being developed as a therapy. Now, why it is being developed as therapy? Let's take one example. In kidney failure, what happens if somebody has failed his kidney, or he or she, the kidney is not working? So what do we depend upon? We depend upon somebody who is very close to donate the kidney. But even somebody donates the kidney who is very, very close, there will be acute rejection. Also, if you look at globally, the list of recipients have increased, and there are very less donors now. It's very challenging. So stem cell biotechnology can help to regenerate kidney organ, right? So that's the nature of stem cell biotechnology. Then we go into a smaller chapter called as biotechnology and medicine. Gene therapy, vaccines, regenerative medicine, so on and so forth. Then we talk about DNA forensics are a very important part of our society and justice. And what does it depend upon in certain cases? They depend upon DNA profiling, because that DNA becomes a source of absolute proof. Now, there are many companies that are being developed that can detect DNA and sequence the DNA to find out the right culprit, so that there is no innocent victim there, and the right justice is delivered. So again, it comes back to the fundamental knowledge of DNA, but it has to be made more, the detection of DNA has to be made more robust, such that it helps the society in a positive way. Then so all these things, stem cell, forensic, developing sensors to treat pollutants, all these needs are dependent upon technology, and technology comes from idea, how an idea is protected, right? So patents, we have to patent our idea, we have to patent our product, otherwise somebody will take it and somebody will get the benefits. So we have to be very, very sure. Then everywhere there is ethics with respect to how much we are benefiting, how much we are hurting the nature, how much should we clone human beings, should we, all these kind of questions that we comes to our mind, and what is the boundary of technology, right? We always think that way. What is the boundary at which technology starts hurting us? And there's a limit. There may not be limit. It's a topic of discussion on, should we take care of our healthcare, or should we go on Mars? Or after we go to Mars, should we go to Jupiter? When there's a lot of poverty in the world, should we prioritize healthcare? Should we prioritize giving people food, or should we take a mission to Mars? So all these things we can discuss in this part of the chapter. Okay, so again, this is an asynchronous class. We meet every day from Monday to Thursdays at 1 to 2:30 p.m., but it's not mandatory to meet. This is asynchronous. I will be here, you may not be here. You don't have to be here, but what I will do, on every day, there will be a learning activity, and I'll be posting it as a content folder in the Blackboard. So keep track of the Blackboard. This semester goes very fast. And so keep track of the Blackboard, and most likely you will get an alert and announcement, so on and so forth. I see a question in the chat area. Let me see what the question is. Yeah, somebody's asking, hi everyone, is it okay if we form a group chat? From me, I have no say in this. You can, you know, for your success, you can form group chat, of course, why not? Okay. So any other questions, if you may have, please ask me. So if there are no questions, then you know, I will finish this class and upload the recording for syllabus.
Professor, one question real quick. I know you said that the final and midterm would be in multiple choice. Would the quizzes be in multiple choice as well, or?
Yes, everything multiple choice questions.
Okay. And those would also be they would be on Blackboard, or would they be like in the class? Or?
All the exams will be on the Blackboard.
Okay. All right. Thank you.
All the exams will be on the Blackboard, and it will be available to you from 7 a.m. to 11:59 p.m. on that day. And one thing very important, I'm going to, please listen to me very carefully. I'm going to post an assignment, like for example, very brief assignment on discussion board, and do as early as possible, because that assignment is directly linked to your attendance. And I have to verify your attendance. You're getting me? So I'll be posting that discussion board, because in 2 to 3 days, we'll have to put that. So not everybody is going to attend this class. For example, today, only 6 students are here. So and they're not supposed to be here. But the only way I can mark present is when you do your assignment on the discussion board. Very simple. And that will verify your enrollment to this course. So I will be posting that assignment in a later 1 hour, within 1 hour. Okay. Any other questions? If not, then we finish this class, and I
Hi,
upload.
Professor. I don't mean to interrupt.
No, not at all. Please.
Right. I'd like to take down the number of these students so that we can form the group chat.
Of course, please.
Hold on just for a couple of seconds. Thank you.
No, please. And in the meanwhile, you can ask me questions as much as possible.
Sure. Thank
you. Never hesitate to. So we are in the virtual world. Email me, and there are sometimes issues with email. I try to respond to each and every student's email. If you don't hear from me, come to office hours, because sometimes CUNY has filters which can put your email into junk, and I may not be able to see the content, and I may not be able to remember who is the student for this class. So always put in the subject line BIO211 Summer 2, and then write your questions, and I'll get back to you.
Okay, thank you, Professor. It was nice to meet you.
Likewise, have a good summer, and
you too.
Let's have productive time. Yeah. So did everybody get the phone number? I can finish this meeting.
Oh, just a couple more seconds. Okay, thank you.
Welcome. Bye. Have a great day.